Good morning class. In the previous two videos, we learned how to find the base values, understand what a per unit system is, and how to represent the different parameters using their respective per unit values. In today's video, we are going to understand how to put all of them together and do a single phase per unit analysis. The steps of per unit analysis are as follows. The first thing we do is we choose the S single phase base for the overall system, and remember this is only one value for the whole system. Then we select the voltage base for the different zones, and it usually follows the transformer's voltage ratings along with the transformer turns ratio. Then we calculate the Z base for the different zones, express all these quantities in per unit. And then a new thing I am introducing here is draw the impedance diagram and solve for the per unit quantities. The impedance diagram is just a simple circuit which has a voltage source, which would be some V per unit, some impedances, and then I can have the load Z LPU. And if needed, we convert back to the actual quantities. To make it much more clearer, let's solve an example here. So the question says we have three zones of a single phase circuit as shown below. Use the base value of 30 kVA and 240 volts in zone 1. So we are given the base values for zone 1, and remember the power base would be same for all three zones. Draw the per unit circuit and find the per unit values of source voltage and all impedances. So let's look at all the impedances we have here. So voltage source doesn't have any impedance. At the first transformer T1, we have an equivalent impedance of 0.1 per unit. So I can represent this transformer using just one impedance of some per unit value. This is the old per unit value. We may have to find what is the new per unit value here. And here we have the Z line impedance, which is given in ohms. We'll need to convert this to per unit. Similarly, we have the impedance for the second transformer, again given with respect to its values here. We need to convert it to whatever voltage base and power base we are choosing for the system. And finally, we have the load value, which is given again in ohms, and again we have to convert this in per unit. So I have to convert the voltage source also to the per unit. So I'll have 1, 2, 3 and 4 impedances and one voltage source. So let me divide my overall transmission line into these three different sections. So the first thing we have to select is the S base, which is given to us as 30 kVA. Then we are given that the voltage base section 1 is, or zone 1 is 240 volts. Then we can find out what is the voltage base in the zone 2, which is V base 2 is equal to V base 1 times the turns ratio. I'll get the value here as 480 volts. Similarly, the voltage base for zone 3 can be found out from the voltage base for zone 2. So what I get here is a value of 120 volts. Next we find the base impedances for these three zones. So I can say Z base 1 is equal to V base 1 square by S base 1, which is 1.92 ohms. Similarly, I have the Z base 2, which is 7.68 ohms. And finally I have the Z base 3, which is 0.48 ohms. Next, let's convert these values what we have to the corresponding per unit values. I can say the V source per unit is equal to 220 at an angle 0 divided by 240, which is 0.9167 at an angle of 0 per unit. Similarly, I can find out what is the Z line per unit, which is the Z line value, which is J2 7.68, which corresponds to J 0.2640 per unit. And finally the Z load per unit is 0.9 plus 0.2 J divided by 0.48 gives me 1.875 plus J 0.4167 per unit. Next we have to find the transformer's equivalent per unit values for our system. So for the first transformer, we can find out the Z base old is V base old divided by S base old, which is 240 square divided by 30 kVA. I can find out the Z per unit new value is Z per unit old into the Z base old by the Z base new value, and I get the same value of 0.1 per unit. I can find out the Z base for the secondary side of the transformer also, but I'm going to get the same value here. Let's verify it for one side. So the Z base old here is, for the second side, 480 square by 30 into 10 raised to 3. I can find out the Z per unit new is 480 square divided by 30 into 10 raised to 3 into 0.1 divided by 7.68 gives me back my value of 0.1 per unit. So this transformer has an impedance of 0.1 per unit. Similarly, if I want to find out the Z base here, I can find out the Z base old value here, which is 115 square divided by 20 into 10 raised to 3. I get a per unit value of 0.1378 per unit. So I can say I'm going to represent this transformer with a per unit value of 0.1378 per unit in our per unit system. Next, we have to draw the per unit equivalent diagram for the overall power system. I have a voltage source, I have the first transformer impedance, I have the Z line impedance, I have the second transformer impedance, and I have finally the Z load impedance. So in terms of per unit values, the first is 0.9167 at an angle of 0 degrees per unit. Then I have J 0.1 per unit. I have J 0.1378 per unit. Then I have J 0.2604 per unit. And I have 1.875 plus J 0.4167 per unit. So I can find out what is the I per unit overall here, which is the V per unit divided by the Z per unit, gives me 0.9167 angle of 0 degrees divided by the Z equivalent per unit, where I'm going to add up all these values of impedances, and I get the answer of 0.4395 at an angle of minus 26.01 per unit. Now this I per unit is the current which is flowing through this whole per unit impedance diagram or the whole per unit circuit. If I want to find out the individual currents in each of the zone, I just find out what is the base values for the current in each zone, and I just multiply it with this I per unit value. As we can see here, we just need to find out the I per unit single value, which is very easy, as we can just find out the I per unit with respect to the V per unit and the Z equivalent per unit of my impedance diagram. So in summary, let's look at all the steps required to do per unit analysis. The first step is that we need to find out the S base for the system. Then we find out the V bases for each of the zones for our system. Correspondingly find out what is ZB1, ZB2, ZB3, etc. for each zone. Then represent everything in per unit values, draw the impedance diagram, and finally solve for the current. The simplest formula is I per unit would be equal to the V per unit divided by the Z equivalent, and if needed, convert them back to find out what is the actual quantities. Thank you.